Anything else from the quiz while we're talking about the quiz? Anything else from the quiz? Overall, it was pretty good, right? You can make corrections just like the other quiz. Turn that in, yes.
Are the corrections due the same time the homework due before the test?
Homework and quiz and test corrections are always due by the day of the next test. Homework corrections are due the day of the final. Yeah, I want you keeping up with new homework and just doing old homework when you can.
It's just a question about the quiz.
Sure.
I kind of I wasn't organized as a key, but I put 5-1 equals 51, and then the next one I put 6-1 equals 61. And you scribbled them out, and then you just boxed the first one.
Yes, I only need one. Once you establish, it's like putting a scale on a map and putting it next to every city or something. You just need one scale for me to read that map, right? Unless you start changing the scale, and I'm like, don't do that shit. Make it a new map. So you just need one key for me to read the whole thing.
Okay.
That's the point of a legend or a key, right? Yeah. I didn't take points over there, did I?
You put -1, and then you put no commas, and then you just square it, and you scribble it, and you put -1.
Ooh, I did. Okay. I mean,
For the text corrections, you can only do one for just one.
yeah, you only get one shot at corrections. This is not English class. No first draft corrections and so forth. It's enough to try to keep up with one set of corrections. That's all I let you do. Yes?
Did you just redo the whole thing?
No. Whenever you do corrections, you correct only those you lost points on. Cool? If you want to redo the whole thing, do it. But, I'm not going to make you redo correct work. Yeah. Yes?
Are you having us turn in the same quizzes that we return the page to you with the corrections?
Yes, good. Either another sheet of paper or on the back or next to the problem if there's enough room and you can make it really clear what the new work is. Never change original work. You turn the original in with the corrections in whatever form. Is that cool? Okay, several people have done that already and gotten their corrections back. I think I've only had to give no points to a couple people. If you're going to make corrections, don't trust the same person that made the mistakes in the first place, meaning yourself, right? Maybe go get some help. I mean, if you use the book, you might be able to tease out enough, but you should probably just run it by somebody like me. Come to my office and say, I'm not giving this to you yet. Can you just tell me what they look like? Do I need to work on some of them? And I'll tell you what you need to work on. It's amazing. I'm trying to get you some points back. And what I'm really trying to do is get you to understand what the hell it is. So anything else on the quiz or anything? All right, cool. So let's do this. First thing is, let's talk about the formula sheet that we can use. And I'm open to suggestions on what you want to put down here, because I am open also to shooting your suggestions down. But we definitely want, so the chapter 1 is all definitions, so no formulas or anything there. Chapter 2 is where we start doing histogram stuff. You need to know how to figure out the class width. I'm not going to let you write down the formula for that. You need to know how to figure that out. Range, high minus low divided by number of classes. Cool? So what's the first formulas we really hit?
Standard deviation.
Yeah, exactly. There's this little formula for the mean. I wouldn't even write that down if I were you, because we know how to calculate the average, right? We add and divide by how many there are. That's what that really stands for. Is that cool? But the standard deviation, the variance, let's see. So we have, what kind of variance is this? Population. I love it. Some of you guys are like, what do you mean, what kind? Population. So, what's the difference between the population variance and the sample variance?
N minus 1.
Yeah, this is going to be N, and this is going to be different symbol, but it still means the mean, right? But it's the sample mean. And it's adjusted because it's just a poor little sample, dude. So we adjust it a bit. All right, I like it. Cool. So you can have this on your formula sheet. Please listen to me now. Not like you haven't been, but just pay attention. You can lose points for things you write on your formula sheet. If you write something on there that we did not say you could have on there, you will lose points for it. All right, so don't make nifty cryptic notes to yourself, I'm going to assume the worst, and most of the time I can figure them out. For example, the empirical rule. What's the empirical rule say? Oh shit, we just did this the other day. Somebody remember empirical rule? Not chubby dude. Yeah, so within one standard deviation there's how much? 68. Good. Within 2 there's 95. Within 3 there's 99.7. You got to know that. So don't. I always get somebody do some kind of little shorthand for themselves, and I see it. They write it on the back. Like he'll never look on the back of it, or something. Come on, don't do that. You're going to lose points that you can't get back. You can't correct that. You just rewrite the formula sheet. No, you can't correct that. So don't lose points on your formula sheet. That's crazy. All right. So and if you want to, you could write this with a square root. It's up to you. You with me? So if you want to, you can rewrite this as sigma equals the square root some. If you want to. You don't have to. If that's going to mess you up, then don't do it. Just remember, this is the variance. You just take a square root to finish it out, to get the standard deviation. Is that cool? Why did we have to square this stuff in the first place? Why did we do that crazy thing?
Non-zero, or non-negative.
To make them not negative, so I'd actually get an answer that made sense. Otherwise, everything in the world would be 0. The spread is 0 again. Holy shit. So I had to square it to kill the negatives. All right. So what else? Anybody have another formula? What about Z-score? Right? What's the only real difference there?
Population and sample.
What about it? What do you mean? What's the difference?
Averages are different ones for the sample.
Good. All right. So they're exactly the same. It's just one's talking about a population, one's talking about a sample. So they're really the same formula. Are you guys with me so far? Now here's something interesting. What if I knew Z and I want to figure out X? So there's a problem like what data point is 2 standard deviations below the mean or something like that, right? So let me ask you this. If the data point is 2 standard deviations below the mean, what is its Z-score? -2, right? 2 below the mean, so it's -2. You with me? So the question is, if I know this is -2, what's X? So they got to tell me the mean and the standard deviation, but I got to figure out X. So here's where the tiny bit of algebra that we do comes into play. You ready? And this formula we're going to write down kicks ass if you remember how to read it in English. You're not allowed to write notes on your formula sheet. You can only write formulas. But this formula is a note, if you let it be. How do I solve this for X? Oh, shit. Yeah, multiply by sigma. So I get Z sigma. And then what do I do to get X by itself? Add the mean. So let me write it like this. X equals mean plus Z sigma. So how do I read this in English? Watch, you ready? The data point is this many standard deviations from the mean. If I go this many standard deviations from the mean, I get to a data point. So what's the Z-score tell you? A Z-score tells you the number of these away from this to get there. The Z-score tells you the number of standard deviations from the mean to the data point. That is a note that I'm letting you write because it's a formula, right? Math is a different language. If you know how to read it, it could be a note. There it is right there. So it's a formula you can use also. Of course, it's a formula, but it helps you answer the question if you know how to read it. Or just memorize the answer and write that down and use it if you want. So we'll do an example of using that formula here in a minute, but anybody have anything else, suggestions to go on this?
Finding the percentile value.
Yeah, if you do the way the book does it, how do they write that? And it's x plus 0.5 y over and what do they say it equals? Do
They multiply by 100 also.
Yeah. And we'll just say that's equal to p.
Yeah.
Whatever. Sure. If you do that way that the book has the formula. If you do, you can write that down. Any other suggestion? You don't have to write that. If you have no idea what that is, if you've never used it, then don't write it down. Because you can do that in a different way.
Or you can do finding the K percentile.
That one's a process. I'm not going to let you write that down. So like the quartiles and so forth, it's a process. You need to know how to do it. The two-step process, right? Take the percentage and then actually go that far in. Is that cool? Is that all right?
It's a quartile root.
Say again?
It's a quartile root. The Q3 minus
Sure. Sure. I don't even know if I'm going to ask you about it, but that came up in the homework in one place, right? So it exists. I want you to know interquartile range exists, but it's not used a lot, so I probably won't give it to you. So if you want to write it down, you can. If you write it down, you're like, what the hell's that? So don't do that to yourself. All right, any other suggestions? Oh, okay. I don't have that many smart asses in my class.
Answer.
There, you see? Examples of problems? No. So that's it. That's it. That's all you can have on your formula sheet. If you thought of something else later, you got to run it by me first, or else you're going to get that phantom loss of points. It's not good. Okay, so now it's wide open. Let me first do a problem using this, and then I'm going to kick it wide open to whatever you guys want to talk about. Has everybody got what they want here? Also, double check your formulas in the book, because you know how bad I write, and plus some of you are far away. So it really sucks when you write one of these down wrong, and that's why you lose points in the test. So it's I have no guarantees for how you interpret what I've written. So double check it in the book. I love now people are like look in the book. All right, here we go. It's all done. All right, so we're going to use this. So they have to give me, so there's a problem like on the practice test. But let me see. If I knew the mean of something was 1918.7, and I knew the standard deviation was 306.29, yummy. And I want to know what data point would be 1.58 standard deviations below the mean. So my first question would be, what does this mean? What is that reference? Yeah, the Z-score. So the Z-score would be what? Z here would be, negative 1.58. All right, I like it. And what else do I know? These things, right? That was really nice. I wrote the symbol down next to them. I might just say the average is this and the standard deviation is that. So you have to know the symbols. Everybody with me? So how do I do this then? Well, I just plug and chug now, right? X equals the mean plus, well, it's going to be minus. Is that cool because it's negative? 1.58 times 306.29. So I start at the mean and I go down this many standard deviations. So now just plug in the calculator and get what you get. 1434.76. Sure. 1434.76? Yeah, that's what I got. I was going to try to do it in my head, but thank God you saved me. All right. Okay. Is that cool? Are you guys getting that same answer? Mm-hmm. Whenever I crowdsource that, you should double check. Okay. So and that's just like number 2 on the practice test, right? And you don't even have to use the formula, but if you did the work and got the right answer, you actually did what that formula says to do. If you look back at it. All right, so now this is going to be interesting because this is our first review day. So you guys don't know what to expect. I really, that's as much as I've brought with me. So it all depends now on what you guys want to focus on. You can say, can we do an example of this kind of problem? You can be very specific. You can be very vague. Ask me anything.
Can we just move over a little to the left?
Yes, I like that. That's awesome. Left? Or your left? Okay, I was like, holy shit, I didn't do what you want. Yes?
Can you get our homework back? See if there's any...
Sure. You're somebody, I think, that I didn't quite finish. Sure. And Dean, I almost finished yours. So just give it back to me on the day of the test. And I can put it in just so you can look at it and start doing the corrections. Well,
Could we maybe just work through some of the problems, like the practice test, so that we see the stuff?
sure. Do you have a...
Yeah, like for number 10, when it says draw an example of distribution skewed to the right or left, how much does it have to be skewed? Like,
Not
how
much.
Would you think?
If I ask you to draw a situation, you probably want to overdo it to make sure that I understand. You know, if you make it barely not, then I'm like, do they know what that means? So from the reading, because I don't think we talked much about skewed in here, but from the reading and from the homework, what does skewed right mean? Let's start with symmetric. What could symmetric look like? Could look like a normal curve. What else could it look like? I like it. A bimodal, right? Like a little person, fragment waiting to eat. No. All right. What else? It could look like this. Wah. That's exciting. That's called a uniform distribution where everything has the same amount. So those are all kind of examples of symmetric. It just means symmetric, of course, means it'll fold back on itself. So what would skewed right do? It pulls it towards the... Exactly. So this is to the right. So this is a big old chunk of taffy, and I pull it to the right. So it's going to look like this. Whoa. You guys kind of with it? Now these ones are hard to do skew, so I basically do normal curve and then skewed right. There it is. Skewed left would be the same thing, just whoop, turn around. Is that cool? What's up?
That's skewed right down with the other part.
No. Skewed right means you pull it towards the right. So it's like the direction that it looks like it's been pulled in is the direction that it's skewed. All right. Is that cool? Okay. Anything else? It's going to be a very short day of everybody's life. Number 2?
So, I have a question.
Yes.
Like, rather than, like, we divide like this mode, you need a specific, like, you put it, like, divide, noting down the mode, you get the mean.
Well, so in this case, what would be, how would it go? I got the mean, the median, and the mode. What do you think would be the biggest amongst those? What's affected more? So if, in San Diego, this could represent house prices, because it's a big old chunk of houses here, but then you go to La Jolla. So who's going to be affected more by the fact that there are a few values that are very high?
Yeah.
The average. So that's going to be the biggest, right? Now the interesting thing is between these two, what's what? And there were a couple homework problems that got into that. I'm mostly concerned about these guys. The mean is the biggest. The median is smaller than the mean. The median is going to be... Now where's the mode on this picture?
Way on the right.
Where is it exactly? Describe it exactly. The highest point. That's what the mode means, the one that occurs the most. So that would occur the most. And where do you think the median is? Do you think the median is at the same place as the mode? Median is probably a little bit
To the right.
high. Okay, there you go. So it goes in order of small to big, it would be mode, median, mean. And they talk about that a little bit in the book. I'm not overly concerned with all three of those. I'm normally concerned with just these two, and it's really easy to tell which is going to be bigger. Skewed right, the mean gets affected by these larger values, so it gets bigger. Skewed left, the opposite happens. The mean gets affected by the smaller values, so it's smaller. So there were a few homework problems about that. So that shouldn't sound completely... Those of you looking at me like, I don't know, you're telling me you haven't done the homework yet. You got some time. Do it. Okay. Yes?
Oh, do you you answer homework questions?
Oh wait, I skipped somebody over.
Oh.
Somebody asked about number 2, right?
That's
Yes.
fine. I want to go over the whole practice test.
Yeah.
Well, I got the answer key, so, but I don't want to give it to you yet.
I don't want to. I want you to go through them. I don't want you to give me answers. I just want you to.
No. It's more than answers, it's solutions. So I've worked it out.
Oh, okay.
Okay, thank you. Well, if you don't want me, you don't have to take one. But it doesn't just have the answers, it's got the solutions. All right. So when you look at the practice set, we can do some together up here, or we can talk about the idea behind them. And number 2 is exactly like the one we just did a second ago. I know the mean, so what symbol do I use for that? Yeah, mu. And it's a sample, so what should I really use? X bar. And I know the standard deviation is 13, so what symbol do I use for that sample? S. So, I mean, I wrote the formula like this. What else could it be represented as? If I don't know the mu, I know. And if I don't know the sigma, I probably know S. I mean, those are the same freaking formulas, right? So I don't write it twice. Whatever the mean is, goes here. Whatever the standard deviation is, it goes there. So it's not 2 different formulas up there. It's just one. And I want to know what's X for 2 standard deviations below the mean. And what's that tell me? It's 2 standard deviations below the mean tells me what? Z is -2. So now I just got to plug that, and that into the formula. And I really want it, I mean, if you start at 98 and I go 2 steps down and each step I take is this big, do I need a formula for that? No. That's physical. I started at point 98. Every step I take is 13. And I take 2 steps down, where do you end up? You should be able to do that without a formula, but it's got a nice another formula.
On the practice test, you don't have anything with percentiles. Is there going to be something on the test?
Well, yeah, I do, sort of. 1G. Create a box plot of the data, so you have to find Q1, Q2, Q3. Yeah, so, but I could ask you P75, P whatever. Yeah. Cool. And then, so is that cool for 2A?
Yeah.
And then 2B is the same thing, except there Z would be positive 1.24, right? Because it's above the mean. I like it. So let me ask you this. Normally I don't give the answer key out because normally when I do that I have an exodus of students because that's all some people are here for. So hopefully you guys are here for more. Have you guys actually tried the practice test or looked at it a little bit? Or all right. So let me tell you this. This is the first time some of you guys are getting an answer key from me. Some of you guys know this. Don't look at the answer key and do this. Yeah. Yep. That's what I would have done. Right? Because then you get a false sense of confidence. The test is not going to be filled in, and I'm just saying, do you agree with this? So the right way to do this is to do this, and then check against this, and then go back to the sections where you had the most trouble. Or don't do this at all. Just do your homework. If you don't have time to do this, you don't have to do this. Please don't turn these into me. I'm giving the freaking answer key. All right, so don't give them to me. So here we go. Let me give this. Oh, jeez. All right. Who else is really happy we have a long weekend? Who else just found out right now that we have a long weekend? There you go. It's a little gift for you. Monday. Take Monday off. Very nice kid. Take Monday off.
How many questions are going to be on the test?
Normally about 25 or so total. 25, 28. And I already talked about what I mean by that, right? Like this test, I would not say this practice test has 11 problems. That would be so misrepresented. I count A, B, C, D as individuals. So please. This is actually an old answer key, and I couldn't remember. Number 11's not on here because 11 is the one I added. So we'll do number 11. But so if you see something you think might be wrong, you never know. I'm averaging about a 97 on my answer keys, which I admit wholeheartedly because I am a human being, right? Math is not about never making a mistake.
You said you added 11?
Yes, so we're going to do 11 together right now. But so let's do that. So does everybody understand the difference between parameter and statistic now? The beautiful thing is the letters they start with tell you. What does a parameter describe? Population. And what's a key word very often but not always for population? All. Yeah, it won't always be that, but that's a really good key word. If I say 60% of the 38 people I talk to like Game of Thrones, is that a statistic or a parameter? Statistic, because it described a sample that I took, right? Good. So that's the way you got to interpret that. So I'm going to ask you questions like, is this a statistic or parameter? 87% of all gross month students enjoy statistics. Parameter. I'm not asking you, does it sound like it's true? I'm just asking, would it be a parameter or a statistic? It would be a parameter because I said all. I said it real quick, but yeah.
The parameter would be just all, right? Like
The parameter is the percentage in that case. So why is it a parameter? It's because it refers to all. It refers to the whole population, not just a subset of the population. So a parameter could be an average or a percentage, and maybe some other things that we don't know about yet. But it could be an average or a percentage, or in general, some kind of numerical description, right? You with me? So the 87% number, that percentage would be the parameter. And it's a parameter because it references all gross month students. Okay, cool. All right. So this question says, why is this a parameter? 42% of all Americans are tired of hearing about the election. Yeah, it's all Americans, not leaving anybody out. It's the whole population. So what would you change in that sentence to make it a statistic? California would be, if I said 40% of all Californians are tired of hearing, I have to assume that my population is California. If my population was the U.S. and I only picked people from California, I don't know how to pick samples, right? Or I am very lazy and I just said, "You're the U.S. What do you think?" I need a little bit better.
42% of Americans poll.
Okay, good. All right, 40% of the 800 people that ABC had call in. That would be a bad sample, but it would be a statistic because it's talking about a sample that was taken.
So you would use the percentage and the number of how many people you talked to, correct, for a statistic?
Yes, so a parameter and a statistic are the same exact thing. That a parameter just talks about a population while a statistic talks about a sample. So they're either an average or a percentage. So again, if I said 72% of all stat students wish they had a free textbook, then that would be, what is the parameter? It's a parameter because I just said all. Well, what is the parameter? 72%. That's the parameter. So in general, as a statistician, I would always be trying to estimate the parameter by finding a statistic. That's the process. We get a statistic. Why? Because I don't have time to talk to everybody. I look at the sample, I get a statistic, and I try to make an inference about the parameter, the whole population. I like it. So that's the process. Okay, maybe. Okay, I can't read some of you guys at all. Okay, so that's number 11. That's not on the answer key, so now you've got that answer we just talked about. Is there anything else you guys want to talk about? You can practice test, homework stuff.
I guess number 4. Nominal ordinal ratio.
So the big thing on number 4, we should know this now from the first quiz, is if I give you a number, you ignore it, right? Because that's not the data. The data is the answers to the question. So if I say 30% of them were blonde, what was the question? So that's why on the quiz I spelled it out a little bit more. 30% were blonde and 20% had brown hair and so forth. So what was the question? What is the color of your hair, right? So the data is hair color. 30% is how I analyzed the data, right? It's not the data. So what kind of data is that? Yeah, no, it's just names of hair color. I like it. Please, nobody believe anymore that nominal means number just because it sounds the same. Right? Nominal is name. It's not numerical at all. The average temperature was 56 degrees, and normally I put like Fahrenheit or Celsius. That's all I'm ever going to reference because we don't all know Kelvin. Right? In fact, right now some of the guys are like, who's Kelvin? Lord Kelvin. So I'm only going to ever reference Fahrenheit, Celsius. Who remembers what level of data is Fahrenheit and Celsius temperature scales? Is it to be ratio? What has to be true?
There has to be a zero.
The zero's got to mean it was supposed to mean. The division thing can get a little misleading, but does 0 degrees Fahrenheit or Celsius mean that's the absence of heat? Because you can get colder, right? So since 0 is not in the right place, what kind of data is? It's not ratio, it's one step down from that interval. Because you can take differences. You can say yesterday was 2 degrees warmer than today. I don't even know, really. I just know it's freaking hot. What the hell? It's February. Sorry. February. What am I paying taxes for? Sorry.
So if you have the test, if the test is set up like this and you ask the question the same way, do you want more than just the answer? Do you want an explanation?